Welcome to the third episode of the Design Future Manufacturing series. This is the last episode dedicated to the new generation of E800 drives. Let's check this time how is it going to simplify our lives in terms of designing safe machines.
The history of Mitsubishi electric frequency inverters starts in Nagoya Works. Nagoya is the heart of our factory automation division, which incorporates various product sections such as PLCs, HMIs, servos, and of course frequency inverters. From 1981, when the first inverter called FRE was manufactured, we are globally recognized as a leader in terms of design, manufacturing, and sales of industrial variable frequency drives. Nowadays, with increasing awareness of industrial end users, machines are expected to be not only efficient and reliable, but also safe for humans and their surroundings. The new generation E800 drive perfectly fits the idea of a drive which is safe for humans.
Today in our studio we are with Wojciech Bracha, product manager for variable frequency drives. Wojciech, this time the main topic of today's episode is safety in drives. Let's start from the very beginning. Why do we pay so much attention to safety in drives?
20 years ago, 9 out of 10 workers of a sawmill were missing a finger or two. Maybe this is rather a drastic example, but for sure it shows how much a safe working environment was missing. Nowadays, the number of accidents compared to the 90s has decreased significantly, probably by the dozens. There are a couple of reasons for such a change. We are more conscious of our own safety, what is potentially dangerous, what is safe. More often we behave in a safer way. We follow safety instructions with greater care, and we follow them because they exist. Somebody created a set of rules which are designed to guide you through the working environment in a safe manner.
And a safe drive is a part of safer working environment?
A drive can definitely be a part of a safe working environment. To understand the importance of safety in drives, we should refer to the European Machinery Directive, which is a generic document describing how we should design and build a machine which is allowed to operate on the European market. This machine directive also defines machines which are typically considered as especially risky for the human operator. Typical ones that can cause a serious injury are, for example, press machines or any kind of saw.
So does that mean that having proper safety functionality built into a drive is mandatory to comply with European regulations?
Well, designing a safe machine is a much deeper topic, so we should take a broader look at it. The fact if a machine is safe or not depends on the design of the complete safety system, starting with initiating elements such as actuators or switches through safety logic and finishing with executive elements which include a drive. To make it as simple as possible, the European Machinery Directive is a general document which describes what a safe machine should be like, and European standards are supposed to be a more precise guideline on how to design the machine in a way that it is compliant with the directive.
What then are the standards that we are talking about?
As a drive supplier, we are obliged to follow IEC 61800, which is a standard for so-called power drive systems. In Part 5, Book 2 of the mentioned standard, you can find a definition of drive-based, standardized safety functionalities. Apart from that, there are a few different harmonized standards which are connected with safety systems. For instance, EN 13849 describes requirements for safety-related parts of the control system. It also explains how the risk assessment should be performed and finally helps to select an appropriate safety performance level as a countermeasure for identified hazards. Partially similar is EN 62061, which also describes the risk assessment procedure and based on probability allows to select appropriate SIL, so-called safety integrity level, for chosen countermeasures. All of these standards can be found in our CE declarations, which means that our drives are designed in accordance with European directives and applicable standards, including requirements for safety functions implemented in our drives.
I think it's the right time to explain finally in detail what these built-in safety functions are.
True. If we are speaking about our new generation of E800 drive, it is equipped with the most popular safety functions defined in the power drive systems standard, such as STO, SS1, SLS, SSM, and SBC. What is extremely important from our customer's point of view is that all of these built-in safety functions achieve the highest possible safety level, which is PLE or SIL3. What is more, all of these are achieved even in open loop control, meaning that no encoder is needed to achieve the most demanding level of safety. We managed to achieve it by using redundant safety CPUs, which cross-monitor each other and guarantee the highest possible safety category. We can frankly say that E800 is a state-of-the-art drive in terms of functional safety.
Finally, how did these drive-based functionalities help Mitsubishi Electric customers in practice?
Well, the main benefit of using drive-based functional safety is that it significantly shortens the process of machine design. After the risk assessment done by one of two aforementioned standards, taking appropriate countermeasure is simplified if drive safety functions are certified and integrated in the drive itself. As a result, by fulfilling the requirements of harmonized standard, we can presume that the machine conforms to the safety requirements of the machinery directive.
In that case, we can clearly say that the future factory is not only one that collects a lot of data and also uses AI algorithms, but also assures safety on both at data and also on production level.
In terms of the smart factory, there is one more thing we should note about E800. It is a network-oriented drive, not only in terms of control but also in terms of safety. You can manage your safety system with an industrial safety network like CC-Link IETSN, but also using other mainstream safety industrial networks such as ProfiSafe, CIP Safety or FSOE. Certainly, it is a feature that a smart factory drive should include, helping all of us to design safe future manufacturing.